皆さんこんにちは。でもこれは英語で、so I was speaking in English. So I'm today going to talk about ErRuby. It's a Ruby implementation on Erlang. So I'm John Lin. My Twitter handle is JohnLinVC. I'm from Taiwan. I'm a senior engineer at iChef. It's not a restaurant. It's a company who sells restaurant posts, the register, you type and print invoice. And I like programming language, so I learn and search for them, and I always look into all the new coolest language. So like Haskell, Python, Swift, and blah, blah, blah. And one day when I searching for new languages, I found this one, Elixir. And it's a Ruby-like language. It looks a lot like Ruby, but it's running on the Erlang VM. And it's good at concurrency, just like Erlang, and got a feeling of Ruby, easy to use and good syntax. So I just wonder, can we have a real Ruby on the Erlang VM? Just like what we have in JRuby, right? We got JRuby on Java VM. So you have all the nice things of Ruby, and you'll have great concurrency feature of Erlang. We'll get best of both worlds. So, was there a Ruby on the Erlang VM? No, not yet. So, there wasn't one. So I decided, maybe it's time. So let's make Ruby on every possible VM. So I made ErRuby. It's a Ruby implementation written in Erlang. It's running on the Erlang VM, which is the Beam VM. It's open source. It's on GitHub. And the goals are, I want to implement major features of Ruby on Erlang VM. And I want to try to experiment concurrency feature built inside Ruby. And by implementing built-in concurrencies, I want to find, can I find all the possible issues we'll encounter when we try to bring concurrency to Ruby? So what's so special about Erlang? So it got some special features make it good at concurrency. The first one is immutable data. And it got actor model and selective message received. And the last one is lightweight process. So the first one, immutable data. So everything is a constant. So the data of an object, of a value, it couldn't get changed. So like Ruby, we got some method like capitalize, ban. We got tons of methods ending in ban, right? This method will change the object itself. But this kind of method is impossible in Erlang because the value itself couldn't be changed at all. So everything will be the same after you assign value to it. And next thing is, it doesn't only have immutable data, it also got immutable variable. So each variable can be assigned only once. So if you try to assign a variable more than once, like twice, you'll raise error, you just broke. It doesn't like Ruby's constant, right? Ruby constant, even it is all capitalized, but you can reassign it after you declare it, right? So the value of variable is defined at one unique place, which will make debugging more easily. And next one, actor model. So it's a concurrent computation model based on actor and message passing. And message passing is from Smalltalk, just like Ruby. And actors share nothing with each other, so they can only communicate with each other by sending and receiving message. So what actually is an actor? An actor is the minimum computation unit. And each actor has its own brain, its own computation power, and its own storage, store any variable or its state. And actors can only communicate by sending and receiving message. There's nothing like shared memory or shared instance. And each actor has one or more address to get message from other actors. So let's do an example of real world. So email system is actually an actor model. So you can send message from like A to food, from a@food.com to B@bus. And you can also send multiple message to multiple address, like send from m.mars.com to multiple address. But what can actor do when they receive message? They can send more message to other guys, or they can create more actors, or they can change the state. What does this mean? Let's look at an example. So here is the Ruby core mailing list, right? So you can send message when you receive message. Why? Like if I send a RubyKaigi is awesome message to a list, you'll forward the message to all its members. And also, actor can create actors. Like one people can have multiple address. If you host your own email server, you can have infinity address if you would like to. And actor can change its state. So like the Ruby core mailing list, you can send a mail to the Ruby core join. So you can just join the mailing list by sending a message to it. And next feature is selective receive. So actor can choose what they want to process when waiting to receive. Just like me waiting for the call for proposal result from RubyKaigi. So I just ignore every mail except the result mail. Let's see an example. So if there's someone not a member and want to send junk to the Ruby core list, the mailing list server will just ignore it. It won't send message to anyone. And the last feature of Erlang is library process. Because in Erlang, every actors are fundamental to Erlang, just like object in Ruby. So spawning process must be effective. So Erlang process are not actual process like OS process. It's actually green threads. But these threads are different from other programming language, is that they don't share variables with each other. They all have its own stack. So to summarize Erlang, so it's good at concurrency. Why? Because immutable data prevents data racing problem. You don't get racing conditions. And actor model provides great horizontal scaling ability, just like the email system. And library process support the whole concurrency model nicely. So let's go to the point. How do I implement ErRuby in Erlang? So first, let's look what should the Ruby interpreter do. It should parse source code, manage local variable, and create object, and manage instant variable. And you got to define method and invoke method. So let's look parsing first. So parsing is very hard. Because Ruby is a very complex language. It's very hard to parse it correctly. So I built upon the Ruby gem called parser, which can parse Ruby syntax across various Ruby versions. And I make some minor tweaks for the new features. So next one, manage local variable. So let's see a very simple example. Greeting equal hello world, and I want to get greeting out. So this Ruby code will be translated to abstract syntax tree. So we got a begin because we got two lines. And the begin will wrap two subtree. One is LVASGN, which means I want to assign a local variable. And what's the name of a variable? It's greeting. And the value is a string called hello world. And next, I want to get the local variable out with the lvar syntax tree. And the lvar syntax tree says I want to get the variable with name greeting out. So before I introduce how ErRuby does it, let's see how conventional programming language do. So basically, we get a stack, right? So we'll get a stack pointer. And next, we'll just put the greeting to a pointer as a pointer, and you point to an actual string, right? But Erlang is an immutable language, as I said before. So it's nowhere to mutable variables inside for the stack. So how can we do it? How can we create a mutable world in Erlang? The method is called continuation passing. I wikid a lot to find out the word. So the whole Ruby stack is a single dictionary. And the dictionary will be passed as an extra argument when we evaluate in the AST. So after we evaluate an AST, it will return a new dictionary, which will represent the resulting stack. So here is what it looks like. So we got 3 AST. We got to evaluate AST1 first, and AST2, and AST3. So we pass the environment as an extra argument, and you'll returns a new environment. So we can just pass the new environment into the next evaluation, and we'll return a new one. So we just repeat this process again and again. But what should inside an environment dictionary? So first is local variable. We need to have its name and its reference. And we have to have a reference to the self-object, because in Ruby, everything need to be inside an object. And you got to have last expressions return value. And it also need to have ability to push frame and pop frames, so the scope of variables won't get mixed together. So you will also get a content of less frame. So let's see how it works. So first we evaluate the begin. And when evaluate begin, the dictionary will have empty local variable, and you get a self and have no return value. And next, we evaluate the local variable assign. But with the starting environment. But after we evaluate the local variable assign, it will change the environment. So the environment will get entry of greeting, which points to hello world. And we then pass the previous environment into the evaluation of local var. And the local var says, I want to get the name of greeting out. So you'll evaluate and put the result into the return value. So this is how ErRuby get a stack. And next Ruby interpreter should create Ruby objects. So the next question is how to implement Ruby objects. So let's see what Ruby objects like. So it's also influenced by Smalltalk. So every method code is actually code send under the hood. So it's not like actor model. But the major difference from actor is that Ruby object must get response before return, before we can evaluate next expression. And actor models, you can just send the message and just forget it. So how do I implement Ruby objects in Erlang? So I just make every object, every instant, a new Erlang actor, a new Erlang process. And all the object operations are done by message passing. So I couldn't get the direct memory access. I couldn't get ivar and get the memory address of it. I must ask the actor, the object, to get the value out. So it can also update its state after receive message. So this is how it does. So first, we create the object and it will wait for message. And if we get some message, it might return some value to the code stack, or it could update its internal state. And there's 2 types of message we can send to object. One of them is synchronized. Synchronized is like normal Ruby operations, like getting instant variable. So I got to send a synchronized message, and object will return a result to the code stack or the sender. And the next one is asynchronous message. So I just tell the object to do something, and I just forgot it, because I don't need a return value. So each object gets some state. So what's inside its state? It must get instant variables and constant, and a reference to its class. It's very important to know who its class is. and a reference to itself. So let's see how we do instance variables. So here's a very simple program. Conf equals to RubyKaigi, and we want to get the conf out. So in the beginning, we have an object which gets no ivar. So the object states dictionary has an empty dictionary for the ivar. And next, from the code stack, we send a message to the object, which will say who sent it. The code stack sent it, and it's an asynchronous message because after we define a message, we don't actually need any return value. And we want to define an instant variable, and its name is conf, and the value will be RubyKaigi. And after we receive the message, the object will update its state and put the conf to RubyKaigi inside its instant variable dictionary. Yeah. So how do we get it out? So in the beginning, we got an object with a state with conf reference. And next, from the code stack, we just send a message to the object. But this time, we got different type of message. It's a synchronous message because we need to get a return value from the object. And we tell the object says, we want to find the instant variable. Oops, wrong slide. So I want to get the instant variable conf. Sorry. So the object will find its state and respond with RubyKaigi. So next, how should we define method? So here's an example. So we got a class conf, and we want to define a method attend with a parameter Rubyist. And we would just want to return an interpolated string, hello Rubyist. So first, we got a class, conf. And it got no methods, so its method table is empty. So from a code stack, we send a message to the conf class, tell them we want to define a method, and the method name should be attend. And it got argument argument Rubyist. And you'll pass the body AST to the conf class. And it's an asynchronous method. Asynchronous message because we don't need to get the method definition back to the code stack. So after getting it, the conf object will update its method table and save the attend to its state. So save attend to its state. So it will include what? It will include the argument list and the body AST and how many arguments the method has. So long. So next one, how do we invoke method? So we want to execute a method from previous conf class. So I want to attend RubyKaigi. So how do we find method definition? So first, the RubyKaigi object has a reference to the class itself. So you know its class is conf. And next, because we want to invoke the function, invoke the method. So we want to find the instance method from the RubyKaigi object. And the method we want to find is attend. And it will be an asynchronous operation because we want to get something back. But the RubyKaigi object doesn't have the method definition itself. The method definition is stored inside the conf object. So instead of just reply, it has to ask its class for the definition of the method. So you just ask its class, I want to find method attend. And the class will find its method table and find out the method attend and put and return its definition back to the RubyKaigi object. And RubyKaigi object will pass back the definition to the code stack. But it's not finished yet because we just get a definition. We haven't evaluated the method yet. So how do we evaluate method? So just like a stack dictionary we said before. So first, we have to evaluate the argument. The argument is just a string, John Lin. And next, we have to push a frame because we don't want to mess with previous, we don't want to mess the scope of variables. So we got to push a new frame for the method invocation. So what we do here is we just create a new frame and put the value of the previous frame into a variable. And next, we already evaluate the argument, but the argument doesn't have a name. So we bind the value of the argument into the name, Rubyist. So inside the body AST, we can find a value. So after that, we evaluate the body. So after evaluation, the last expression will save its value into the return value inside the code stack. And here, the return value will be hello John Lin. And the last step of invoking method is pop frame. So we need to pop the frame out. But we also need to get the last return value inside to the previous frame. So we update the return value to hello John Lin. So that's how we invoke method. So currently, it is pretty much all the important things Ruby interpreters do, because there's tons of other things, because Ruby is very huge. I haven't finished everything at all. I haven't finished anything yet. And the current feature of ErRuby is we got local or instant variables. I don't have classic variables yet. And we can define method and call this method. And we also got class, and we can also inheritance from class. And I didn't explain here, but I also get block, and we can have yield. So we can pass a block to the function definition and use yield in the definition. And I got some basic data types like Boolean, integer, string, and array. But because like string, Ruby strings got tons of methods, so I haven't finished everything at all. I haven't finished anything yet, all of them yet. So next, some experimental features. So these are the C Ruby and other Rubies didn't have, but I want to try it out. So one interesting thing is I want to introduce first-class concurrency to ErRuby. So it's one of the main goals of ErRuby because I make ErRuby for experimenting, not for production work yet. But if anyone wants to get it works on production, please contact me. We can work together. And the concept behind first-class concurrency is very Ruby's. The first-class concurrency should make programmers happy, not the machines, right? So the interface itself is very important. And I want to follow the principle of least astonishment, which means the feature itself shouldn't surprise anyone. So here is the syntax. Full pipe dot bar. So this syntax has no impact on existing code because it's illegal in current Ruby, right? So if you write pipe dot, it's illegal. So it has no impact on existing code. And it's inspired by actor model and Go routine. And the symbol is why I choose pipe, because it's a straight line, so it feels pretty concurrency itself. And another reason is or. Pipe means or, right? So or is a good friend of and we already got and in Ruby. Well, we already got and dot in Ruby. So here's an example. So first, maybe we try to define some method like upload file. Upload file may take some 1 or 2 minutes. And another function, another method is send heartbeat. So like in WebSocket, we have to send heartbeat to a client like every minute, right? But how should we do that? Because in current implementation, we got to call like thread or call another process to send the heartbeat. But here, we just call pipe.upload file. And you will just run the upload file in the background. And we will proceed to the next expression immediately. And we can call the pipe.send heartbeat. So you send heartbeat also in the background. So that we can do other stuff. So these previous codes won't block the current thread, current process. And at last, we can get the value from the response of a pipe dot. So what it does? So it does asynchronous method coding. So unlike conventional Ruby function, if the text is very huge, you must wait until the text is finished. But here, it won't wait. You will return a future object immediately, and which will wrap the return value of the method code. But when we will block, it will block if we actually need a result from the method. So how it works under the hood. So I create a new process, new Erlang process, not OS process, for the method itself. And it will return the future object immediately. And the computation will continue. And after the computation finish, you'll send the value back to the center of the invocation. But if you want to get the result before the test is done, you'll just block and wait for the result. So what is a future? So there's tons of futures. Each of them have different definitions. But here, I use it as a proxy object. So it doesn't get the and then or like on arrow stuff. It's just a plain Ruby object. So it's a proxy object represent the result of a computation event. And it can be passed around just like normal Ruby objects. But when you access the value, you'll block and wait for a result if a result is not ready yet. So let's see how the time frame works. So say if we invoke a pipe.bar in the beginning of time and assign it to future, right? And the bar method will run concurrently in the background. But if we access it before the running ends, it will block the current thread and wait for the result. But if we delay the access, so if the task was finished before the access of the value, the access will return immediately. So you just feel like there was no blocking at all. You don't have to code join or other stuff. But the question is, when do we actually need a value? Because the later we get a value, the better concurrency effect we get. If it blocks right away, if we access value right away, we don't have any concurrency at all. It's just like normal function calls. But fortunately, some operations of variables doesn't need the actual value. So first, if we assign the future to a variable, we don't actually need a value when we assign the future to a variable. Because a variable is just a reference to the object. We can just reference the future object instead of the real object. And another one is invoking functions on the future object. In this case, we need the actual value because we need to find out the class of the object. If we don't know the class, we couldn't find the definition of the object. So we should block and when call method on the future. And next one is language constructs. Like if I want to put hello if future. So in this case, I need to know the value of the future, because in Ruby, we only evaluate if future is nil, and we shouldn't print anything out at all. So in this case, we will actually need a value of the future. So we'll block in this case. And the last case is, what if we pass the future as an argument of a method? There's actually two types of methods to consider. One is user-defined, the code we write ourselves. And others are language built-in methods, which are implemented by the language. So for example, like the Ruby, like the attend function we just defined. So inside a user-defined method, actually a user-defined method actually do following things. One, you either assign it to a variable, or you can call method on it, or you can pass it as argument. But in either case, we don't have to decide anything at all, because these are a user method is just a wrapper around all these cases. So there's no need to access the real value when the future is passed as an argument. So we don't need to block in this case. And the last case is, if we pass it to a system method or a language method, because a language method is a method that do actual works. So it will need a value to do the actual works. So we'll block in this case. So but what it doesn't solve? It doesn't solve one of the most critical problem, the data sharing problem. And it also doesn't solve raising condition. Actually, it's just a syntax sugar of like process, but you get better syntax. So what's the future challenge of ErRuby? The first one is, we just mentioned before, like we got to find a better way to handle data sharing between processes. So like pipe dot, we got to find a way to make pipe dot atomic or like protected from racing conditions. And another one is garbage collection. It doesn't have garbage collection yet because I haven't got time to implement it. And next one is exceptions, because exceptions are pretty hard to implement. So the takeaways, conclusion. So ErRuby is an experimental Ruby interpreter on Erlang. And it's totally possible to implement Ruby on a functional language, which got no side effect at all. And I feel pipe dot fits pretty nicely into Ruby. Okay, so thank you for listening. And I think we got some time for Q&A, but let's list some common questions. So ErRuby is at GitHub. And my Twitter handle is JohnLinVC. So if you got any question about ErRuby or me, you can just ask me on Twitter. So, questions?
Thank you.
Hi. Thank you for interesting presentation. By the way, are you going to use this ErRuby in your other products in near future?
LV.
Are you going to use this Ruby?
Yes, I might use it in my personal cases. Yeah.
Thanks.
I was really excited when I see this project at first. I was wondering that how could you implement the thread or these things with Ruby? You know that when using Elixir, that you have to think in Erlang way. It is just sometimes syntax-like. So I was considering that you are saying that you are implement the whole Ruby. So that I was wondering that how do you implement the thread process? Do you have the GIL problems, or since like that, I've just wrote a few test code and it met an error. So that I would rather to ask you about how about your think about it.
Okay, so your question is, how do I handle thread or process in ErRuby?
Yes, but you know that you are implement a whole Ruby, but not just a new your own self actor method on Ruby, right?
Yeah. So, yeah. So I implement the whole. My target is implement the whole Ruby, not just part of it. So my goal is to provide most useful use case of Ruby. Yeah. Let me see. Let me think. Sorry. But we can talk later. Sorry. Any more questions?
Thank you for your great presentation. What do you think is what's the main use case of ErRuby in software products?
Okay. So your question is, what will be the main use case of
Yes.
ErRuby? So one future possible use case is use it alongside with normal Erlang, just like JRuby. Because in JRuby's case, some people use it as a glue to glue multiple Java programs together. So one of the possible use case of this is you can glue different Elixir or Erlang program together by invoking the native Erlang or Elixir method. So act as a glue.
Okay, thank you very much.
I have two questions. So the first question is, how much memory consumption you thought about? So because passing the AST will consume the huge memory per process.
Okay, so what's the memory consumption of this? I haven't benchmarked it exactly, but I think in Erlang, because everything is immutable, so the values will get reused. So for example, when I reference in the previous frame, because it has the same content of the previous frame, so you will just reference it for me. So like pushing stack, inside the machine, the memory consumption will be more likely to behave exactly as traditional stack. So you won't have like exponential memory consumption.
Okay, thank you. And another question is, what happens if the future object fails? So are you going to introduce a new exception class or Ruby or another kind of mechanism like a syntax or something like that?
Yeah, so this is one of the future goals. But in my mind, it should work just like normal Ruby. Because in this case, we got all the continuation, all the stack. So we can just raise it from there. So I think the exception handling should be as identical as normal Ruby as possible.
The programmers have to care about when handling the exception if you use multiple asynchronous method calling.
Yeah.
Okay,
Yes.
thank you.
Please, this is last question, please.
Thank you for the presentation. So you said having a feature in the conditional of if blocks, but passing a feature to some method doesn't block. So what is the difference between having feature in condition and passing to method?
Okay, so your question is, if I pass a future to the if, it will blocks. But if I pass a future to a user function, user method, it doesn't block. Because, okay, so this is the question. So my answer is, actually, if is more like a system function. So you do something if the argument is true or some object. You don't do things when it's false or it's nil, right? So actually, language construct is more like system built-in function. So it should behave just like system built-in functions.
So future is not a first-class object in Ruby, right?
Sorry?
A future is not a first-class object in Ruby. First-class object. It's not normal object. It's something special.
No, it's a normal object. So the implementation will be, I will ask is if you are a future. So if you are not a future, I'll do nothing. So there will be a hidden implementation method inside.
I see. Yeah, thanks.
Okay, thank you for listening.
Thank you very much, John-san. Thank you again.